Hello, my name is David Philpott. I'm a third-year engineering student in the laboratory of Kelley at the University of Toronto. And today I'm here to talk about the 3D printing microfluidic project that we have going on in our lab. We develop microfluidic devices to be able to sort cells based off of protein expression. And in the first generation of the chip, it worked quite well. So one of the projects that we're working on right now is to be able to use 3D printing to be able to increase the amount of chips that we can make and the amount of samples that we can process. So we've been working with CADworks3D to be able to take our current photolithography-based chip design and convert it to a 3D printing high-throughput chip. Our chips were initially created using photolithography. This required over an entire day in the clean room where you're paying rates of $70 per hour to use the equipment, and we would get about 20 chips over the course of an entire day of work.
But now with 3D printing,
we can be able to print a chip in only 20 minutes, at quite lower cost compared to the user fees of the clean room. This is one of our older chips that have been created using traditional microfabrication techniques. To be able to create it, it takes about 3 days to be able to create 20 devices, whereas our new 3D printed chip, we can be able to print out in only 20 minutes and use the same day that we make it. So one of the projects that I'm doing is using 3D printed microfluidics to be able to create a new design of the chip that takes 16 designs of the previous chip and runs them all in parallel. And this is the outcome of that, where we have a 3D printed device with a manifold system designed within, such that you have a common inlet for the cell sample and for the outlet populations. They get split into 16 different branches to be able to be sorted within the next generation mixed chip. Well, the initial device was a success, and we were able to use it for an interesting application and have the design published. But within the lab here in the Kelley Lab, we see the potential for commercialization of this technology. One of the things that's required to be able to do partnerships with industry partners is to be able to have a technology that's easily deployable outside your own laboratory. So what the 3D printed version of the mixed chip does is allow us to be able to deploy this technology to our partners in the United States and around the world. The learning curve for being able to develop 3D printed microfluidics is not too difficult. Many of the people who are developing microfluidics will have CAD experience, which will help tremendously. We do most of our work in Fusion 360 because it's cloud-based and you can share your designs with other people in the lab or with collaborators. But any 3D version of CAD software like AutoCAD or Inventor or SolidWorks, there are some design parameters that you have to follow because not everything that can be designed can actually be printed. But working with CADworks3D, they use their tremendous experience to help you come up with designs that are going to meet your needs.